Hey everybody, Mr. Canyon here, just going through this assignment that we started in class. Some of us finished it, but it's a great review for the test coming up, so I thought I'd make a quick video on this Saturday, working on the weekend. So, here are some statistics that are given. So they give us, it's the high temperatures in the city during October. They give us the mean, the median, the standard deviation, and the IQR, the interquartile range. They give us the equation to convert from Fahrenheit to Celsius. We have to take 32 away, then multiply that difference by 5/9. So describe how the value of each statistic changes when 32 is subtracted from the temperature. I believe what we stated in class was this, that the mean and median would just end up being 32 less. We're just thinking about this subtraction. However, the standard deviation and interquartile range would be unchanged because those are just a measure of variability. If the whole data set is just shifted down 32 units, the variability of the data, or how spread out it is unaffected, but the measures of center are of course shifted. Okay, so let's go to the next one. Describe how the value of each further changes when they're multiplied by 5/9. Well, if you think about it, if our data set, every data is multiplied by 5/9, they all become a little bit less, but also the difference between them becomes less. So this would affect all of the 4 measurements by a factor of 5/9, meaning they're all going to be 5/9 times what they would be. Of course, the last question now, how would each one change? Well, it's sort of a combination of the first two. So the mean and median, you would subtract 32, then multiply that by 5/9, and the standard deviation and IQR are simply 5/9 times what they were in Fahrenheit. Good spelling there, Mr. Tan. I think you spelled it correctly. Okay, so now we're on to the next one. We have a box plot. Give an example of a box plot that has a greater median, so this line has to be to the right, and a greater measure of variability, meaning we're going to just need to make the box wider to give IQR bigger, show us that they're spread out, but the same minimum and maximum. So let's see, my minimum's at 15, it looks like. My maximum is at 95. My median has to be greater than 50, so let's go to 60. And then I just need to make my box more spread out. So I'm going to spread this thing out nice and wide. I'll go up to 85 and all the way down to 20. Can't forget my whiskers. And I made my box and whisker plot, aka my box plot. Not too bad on that one. Okay, now they're talking about vitamin C level in dogs. They tell us the mean level is 7.6 milligrams per liter. The standard deviation is 2.1. One dog's vitamin C level was not in the normal range. It was 0.9 millimeters per liter, which is very low. If the value is eliminated, what happens to the mean? Well, if we eliminate a value that's very low in the data set, if you think about all the numbers we add up and divide, now we don't have this one that's very low, so it's going to increase the mean. If 0.9 is eliminated, because it's so much less than the mean of 7.6. Okay. If the value is eliminated, what happens to the standard deviation? Well, standard deviation is a measure of variability, so if we eliminate an outlier, well, I guess I shouldn't say outlier because I haven't done the test, but I kind of think it is an outlier. Eliminating the 0.9 data point decreases the standard deviation because this is furthest from the normal range as described in the given information, right? It says it was not in the normal range. So when you remove things not in the normal range, whether they be outliers, the variability is less, right? We've removed something that's, so the standard deviation would decrease. Okay, question 4. Number of hours 15 students walked during a 2-week period. Wow, we got one big time walker, 30 hours. We've got a median of 10, they're telling us. The first quartile would be an 8. The third quartile is 14. And the interquartile range is 6 hours. Are there any outliers in the data? So this is a little bit trickier because we weren't sure whether or not. Okay, let me see. Will this let me draw? This could be good. I've never used this before. Nice. So what we could actually do here is a little bit of an investigation, because you may remember some people said they were confused about that, but 1.5 times the IQR, or the interquartile range, allows us to figure out if something is an outlier or not. Because if it's that much above the third quartile or more, or if it's greater than that, it's a outlier to the right. If it's less than the first quartile minus that same value, it's an outlier to the left. Whoa, I didn't mean that. How did I'll have to figure that out. I wonder how I zoom out. So it looks as though if I exit my drawing, okay, there we go. Oops. Well, let me see if it comes back. Oh, no, it didn't. But it looks like the 30. Let's figure it out. Well, the IQR is 6 hours. So if I do 1.5 times 6, that gives me 3/2 of 6, which is 9. I'm testing really 30. This is the one that looks the furthest. It just jumped out to me. If I take the third quartile, 14 plus 9, is it greater than that value? Yes, it is greater than 23. 30 is greater than 23. Therefore, it is an outlier. Excuse my handwriting. I think I left my drawing tablet at school. So we'll say yes for this one. Why? It is greater than 1.5, or sorry, the third quartile plus 1.5 times the IQR. And if I really wanted to show, I could say 30 is greater than the third quartile, which we said was 14, plus 1.5 times 6, which I could say, which simplifies to 30 is greater than, that was 9, using my order of operations, is greater than 23. Exclamation point, because I feel so enthusiastic. Here are some summary statistics about the number of accounts that follow some bands on social media. You can see the mean is about 16,000, the median a bit more, standard deviation 3,200, about 300, first quartile, third quartile, IQR all given. So right away I could see the third quartile plus 1.5 times the IQR. I could add 9,000 to be safe, right? Because I just did 6 times 1.5, which is 9. So if I round this up, I'll be very safe. A very popular band, I could say 30,000, because that would be 28. So if a band has 30,000, some people might say, what if they have 1 million followers? Well, that's definitely an outlier. And again, I could say because this is greater than the third quartile plus 1.5 times the IQR. I think that's enough. I could get the calculation, but I've chosen such a ridiculous number. Of course it's greater. Adriana had a good answer then, a relatively unknown band. Well, Adriana shared, well, if they had one follower, maybe I should put followers here. That's maybe not relatively unknown. That's completely unknown, but it is correct. I could say maybe 100 followers because that is less than Q1 minus 1.5 times the IQR, which would be about 9,000 less than this. So even if it's 1,000 or 2,000, it would still be good, I think. All right, so this was one we said there could be an argument made for both. However, the weights of one population of mountain gorillas, I love mountain gorillas personally. They're beautiful creatures. They have a mean of 203 pounds and standard deviation of 18 pounds, while another population has a mean of 180 and a standard deviation of 25 pounds. Andre says the two populations are similar. Do you agree? Well, I said yes, I did agree, because there would be a lot of overlap in the two data sets, because it definitely goes about 18 below and 25 above the 180, so there would be a lot of overlap. But I could see you saying disagree because the means are so far are 20 pounds different. But I would say yes, because the data sets overlap based on the means and standard deviation. Okay, I think we're on to the last one. Let's take a look. Here we have two box plots. One, amount of change 50 people were carrying. One, though, the maximum 203 was removed. Wow, look at that whisker drop down. The median is the same. It was an error in recording, that's why they removed it. Explain why the median remains the same when 203 cents was removed. Well, I think somebody, maybe it was Calliope in one of our classes, shared that the median is a measure of the middle value, right? Not the average. So removing an outlier does not necessarily change the median. It's definitely going to change the mean, which I may be spoiling the next one, but there could be a lot of folks that had 25 cents in their pocket, that much change. And so even eliminating a top value does not change the measure of center, the median measure of center in this case. However, what would happen to the mean if I remove that 203 outlier? Well, now we've removed a whole sum of 203 being added to the numerator in our mean calculation. So the mean would definitely increase because outliers pull the mean toward them. I like that. Because outliers pull the mean toward them, this elimination of a large outlier of 203 would decrease the mean. Not too bad in this problem set. I also assigned the problem set the lesson 16 additional practice problem set. I would recommend you try that before Wednesday's assessment because these are cumulative sets, so you can see they quiz from all sorts of lessons we've worked up through, right? A lot of this is comparing data sets, so it's built quite nicely on itself. Don't forget to look over your notes about categorical data, that sort of thing, but I hope you all have a great weekend and find this video to be helpful. Much love, Mr. Tannen, signing out.